Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to learn about a graphical representation of polynomials. A very important topic. So now we have to discuss about the representation of polynomials in the graph. So see here we have three types of polynomials: linear polynomials, quadratic polynomials, and cubic polynomials. So first let us discuss one by one. First we have to discuss about linear polynomials. So the general form of a linear polynomial is ax plus b. A is not equal to 0 and a comma b are the real numbers. So here the graph of a linear polynomial ax plus b is a straight line. The graph of a linear polynomial y is equal to ax plus b is a straight line. So the degree of a linear polynomial is 1. The degree of a linear polynomial is 1. So here see, the graph of a linear polynomial is a straight line. If the straight line intersects the x-axis at a point, the x-coordinate of the point is the zero value of a linear polynomial. So this is very important. So we can find the zero values of the polynomials using the graph. By drawing the graph of the given polynomials, we can find the zero values. So here the graph of a linear polynomial y is equal to ax plus b is a straight line. If the straight line intersects the x-axis at the point, then the x-coordinate of the point is the zero value of the linear polynomial. So see here what it is. In general, for a linear polynomial ax plus b, so a is not equal to 0 and a comma b are the real numbers. The graph of y is equal to ax plus b is a straight line which intersects the x-axis at exactly 1 point minus b by a comma 0. So this is the graph of the linear polynomial. So the straight line y is equal to ax plus b. This straight line is y is equal to ax plus b. The straight line is intersecting the x-axis at the point minus b by a comma 0. Here the x-coordinate of the point minus b by a is the 0 of the linear polynomial y is equal to ax plus b. So that is the meaning of a graphical representation of a linear polynomial. So we can say that therefore the 0 of linear polynomial ax plus b is x is equal to minus b by a. Here minus b by a is nothing but the x coordinate of the point where the straight line is intersecting the x-axis. So this is the 0 of linear polynomial. The 0 of the linear polynomial ax plus b is x is equal to minus b by a. And we can say that a linear polynomial has at most 1 0. Since the degree of the linear polynomial is 1, a linear polynomial has at most only 1 0. So this is about a graphical representation of linear polynomial. So next we have to learn about the graphical representation of a quadratic polynomial. So now we have to learn about the graphical representation of the quadratic polynomial. So what is the general form of a quadratic polynomial? Ax square plus bx plus c, a is not equal to 0 is a quadratic polynomial. So what is the degree of a quadratic polynomial? The degree of a quadratic polynomial is 2. So here the general form of a quadratic polynomial is ax square plus bx plus c and a is not equal to 0 is the condition. So the graph of a quadratic polynomial y is equal to ax square plus bx plus c is a parabola. So the graph of a quadratic polynomial y is equal to ax square plus bx plus c is a parabola. So here we have three cases. So if we draw the graph of a quadratic polynomial, we may get any one of these three cases. If we draw the graph of a quadratic polynomial, either we may get the first graph or the second graph or the third graph. Only these three cases are possible if we draw the graph of a quadratic polynomial. Suppose if we get the first type of graph, so this is the curve is called the parabola. This curve, the name of this curve is parabola. Simply you have to remember that the graph of a quadratic polynomial is a parabola. So the name of this curve is a parabola. So in the first case, the parabola is intersecting the x-axis at two distinct points. So here the x-coordinates of the points where the parabola is intersecting the x-axis are the zeros of the quadratic polynomial. Suppose here let the first point be x1 comma 0 and let the second point be x2 comma 0. Now x1 comma x2 are the zeros of the quadratic polynomial in this case. Since the parabola is intersecting the x-axis at two distinct points and so it has two zeros, the zeros are x1 and x2. They are the x coordinates of the points where the parabola is intersecting the x-axis. So these two are the zeros in this case. So suppose if we get the second case of graph for the quadratic polynomial, if we draw the graph of quadratic polynomial, suppose if we get the second case graph, so if you observe here, the parabola is intersecting the x-axis at exactly one point. So in this case, the quadratic polynomial has two equal zeros. So here let the point be as x comma 0. Here the zeros are, here the zeros of the quadratic polynomial are x comma x or x and x. So in this case the zeros of the quadratic polynomial are x1 and x2, So these two are the two distinct zeros, but these two are the equal zeros in this case. Suppose if we draw the graph of a quadratic polynomial, if we get the third case graph, it is very clear the parabola is not at all touching the x-axis. So we can say that the quadratic polynomial has no real zeros. So in this case it has no real zeros. So no real zeros in this case. So one thing you have to understand here, if the curve intersects the x-axis in one point, then the polynomial has 1 0. If the curve intersects the x-axis at 2 points, then the polynomial has 2 zeros. If the curve intersects the x-axis at 3 points, then the polynomial has 3 zeros. That you have to remember. So see here, this is the graph of the quadratic polynomial. So simply you have to remember a quadratic polynomial has at most 2 zeros. Since the degree of the quadratic polynomial is 2, it has at most 2 zeros. The graph of the quadratic polynomial y is equal to ax square plus bx plus c is a parabola. So it may has first type, second type or third type of the graphs. So here the parabola is intersecting the x-axis at two distinct points. Here it is intersecting at exactly one point. Here the parabola is not at all touching the x-axis. So in the first case the x coordinates are the zeros, and the here two equal zeros it has. Here there are no zeros, that means there are no real zeros for the quadratic polynomial. So this is the graphical representation of the quadratic polynomial. It is very, very important. Every time he is asking for 4 marks in this area, definitely you can get to 1 4-mark problem from the graph. He asked like this: draw the graph of the quadratic polynomial and find the zeros from the graph. Very important, you have to learn. So this is the quadratic polynomial, representation of the quadratic polynomial and the graph. So next we have cubic polynomial. So just you next cubic polynomial, just you have to remember the general form of a cubic polynomial is ax cube plus bx square plus cx plus d. A is not equal to 0 is the condition. So see here, the general form of a cubic polynomial is ax cube plus bx square plus cx plus d. A is not equal to 0. Here the degree of the cubic polynomial is 3, hence it has 3 zeros. You have to remember, a cubic polynomial has at most 3 zeros. So how many zeros it has? A cubic polynomial has at most 3 zeros. So if you draw the graph of a cubic polynomial, you can get the following graphs. Suppose this is one of the graph of a cubic polynomial. Here the curve is intersecting the x-axis at 3 distinct points. So the x coordinates of these 3 points are the zeros of the cubic polynomial. So this is only one type of the graph of a cubic polynomial. So we have only graphs of quadratic polynomial in our syllabus, but this is the graph, one type of graph of a cubic polynomial. So here the curve is intersecting the x-axis at 3 distinct points, hence it has 3 zeros. So now let us solve some problems from second exercise. Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to solve some problems from second exercise. So here he has given some graphs. He is asking to find the number of zeros. See here, the graphs of y is equal to p of x are given below. For some polynomials p of x, in each case find the number of zeros of p of x. So he has given the graphs of polynomials p of x. He is asking to find us the number of zeros. So this is the first one, second and third. Totally we have 6 graphs in the first question. So I have drawn 3 first. So one by one we have to discuss. This is the first graph. So he is asking to find the number of zeros. So how can we say? Just a simple, you have to remember that we have to observe the curve, whether the curve is intersecting the x-axis or not. If it intersects the x-axis, at how many points it is intersecting the x-axis, now we have to count. So see here, the graph is not at all intersecting the x-axis. So here there are no zeros. So here we can say a number of zeros equal to 0, since the graph is not intersecting the x-axis. Number of zeros is equal to 0 here. So in the second case, the curve is intersecting the x-axis at only one point. So here the number of zeros equal to 1. Number of zeros equal to 1. Depending upon the points of intersection of x-axis, we can decide the number of zeros. So here the graph is intersecting the x-axis at 3 distinct points, these 3. So therefore in this case, number of zeros equal to number of zeros is equal to 3 here. So this is very important for objective type student. Every time he is asking at least 1 from this area. So just simply you have to observe the curve is intersecting the x-axis or not. If it intersects it, how many points it is intersecting, just you have to count. Here the curve is not intersecting the x-axis, hence number of zeros equal to 0. Here the curve is intersecting the x-axis at only one point, therefore the number of zeros equal to 1. Here the curve is intersecting the x-axis at 3 distinct points, therefore the number of zeros equal to 3. So next we have 3 more. We have 3 more graphs in the first question. See here, this is the fourth one. Again the parabola here intersecting the x-axis at 2 distinct points. So depending upon the point of intersection and the x-axis, we can decide the number of zeros of a polynomial. So here the curve is intersecting the x-axis at two distinct points. So here the number of zeros is equal to 2. This is the fourth one. So next, fifth graph. So now again we have to count the points of intersection of the curve and the x-axis. Here the curve is intersecting the x-axis at 1, 2, 3 and 4. So the curve is intersecting the x-axis at 4 distinct points, 1, 2, 3, 4. Therefore the number of zeros equal to 4. So this is the fifth graph. Next, sixth one. Again we have to count the points of intersection of the curve and the x-axis. The curve is intersecting the x-axis at 1, 2, 3 distinct points. Therefore the number of zeros is equal to 3. So simply we have to observe the points of intersection of the curve and the x-axis. Then we have to count the number of points of intersection. So easily we can decide the number of zeros of the given polynomial. So very important for a one marker objective type. Just you have to count the number of points of intersections. So this is the first problem in the second exercise, student. Next we have to solve the second problem. This is the second problem in second exercise. See here what he is asking. Find the zeros of the given polynomials. First one, p of x is equal to 3x. Totally there are 4 bits in the second problem. So this is the first one. He has given p of x is equal to 3x. He is asking to find as the zeros. So see here how can we find a solution. First let p of x is equal to 0. So let p of x is equal to 0. So what is p of x? Here p of x he has given that 3x. 3x is equal to 0. Now we have to find the x value. X is equal to 0 by 3, which is equal to 0. Therefore the 0 of p of x is equal to p of x is equal to 0 only. That's all, very easy. So this is the first one in the second problem. So next we have to solve the second one. This is the second bit in the second problem. So find the zeros of the given polynomials. Here he has given second one. It is p of x is equal to x square plus 5x plus 6. So first let p of x is equal to 0. By we have to equalize the given polynomials to the 0, and then we have to find the value of x. So see here, let p of x is equal to 0. So p of x he has given that x square plus 5x plus 6 is equal to 0. So now we have to find the factors. So the coefficient of x square is 1 and the constant is 6. 1 into 6 is equal to 6. Now we have to find the factors for 6. So we can write 2 into 3 is equal to 6. Yes, but their sum should be the product of x coefficient. So their sum should be the coefficient of x, that is 2 plus 3 is equal to 5. So here 2 and 3 are the factors. We can write x square as x square, right, as usual, but this 5x write as 2x plus 3x, write 6 as usual. So this is the factorization by splitting the middle term. So here in the first two terms, in these two terms take x as common, we can get x plus 2. In these two terms take 3 as common, we can get again, here we get x, here we get plus 2 is equal to 0. So in these two terms totally x plus 2 is common, x plus 2. So here we get x, here plus 3 will be. So x plus 2 into x plus 3 is equal to 0. So therefore we can write here either x plus 2 is equal to 0 or x plus 3 is equal to 0. So here we get x is equal to minus 2 or x is equal to minus 3. So these two are the zeros of p of x. Therefore zeros of p of x is equal to zeros of p of x is equal to minus 2 comma minus 3. So since the given polynomial is a quadratic polynomial, it has two zeros, minus 2 and minus 3. So this is the second bit. Next we have to solve third bit. This is the third bit in the second problem. Again we have to find the zeros of the given polynomial. So see here, p of x is equal to x plus 2 into x plus 3 has given. So by equalizing p of x is equal to 0, we have to find the values of x. So here let p of x is equal to 0. So that implies p of x is x plus 2 into x plus 3 is equal to 0. So it is very easy. The product of these two equal to 0, only it is possible either x plus 2 is equal to 0 or x plus 3 is equal to 0. So any one of these two must be equal to 0, then only their product is equal to 0. So here x is equal to minus 2 or x is equal to minus 3. Therefore the zeros of p of x, zeros of p of x is equal to minus 2 comma minus 3. So very easy. So this is the third one in the second problem. So we have one more. Next we have to solve fourth one. This is the fourth bit in the second problem. It has given p of x is equal to x to the power 4 minus 16. So by equalizing p of x equal to 0, we have to find the values of x. So the values of x are the zeros of the p of x. So let p of x is equal to 0. That implies x to the power 4 minus 16 is equal to 0. So now this x to the power 4 I am writing as x square whole square minus 4 square is equal to 0. So now it is in the form a square minus b square. So a square minus b square equal to a plus b into a minus b. So that is a plus b is x square plus 4 into a minus b is x square minus 4 is equal to 0. So here we can write x square plus 4 right as usual, but this x square minus 4 can be written as I am writing as x square minus 2 square is equal to 0. So here I am writing again x square plus 4 into, again it is in the form a square minus b square. So a plus b into a minus b, that is a plus b is x plus 2 into x minus 2 is equal to 0. So therefore we can write x square plus 4 equal to 0 or x plus 2 equal to 0 or x minus 2 is equal to 0. So here if x square plus 4 equal to 0, take plus 4 to the right side, we can get x square is equal to minus 4. Here x is equal to plus or minus square root of minus 4. So here we can get x is equal to minus 2. Here we can get x is equal to plus 2. So therefore zeros equal to, zeros of p of x equal to, zeros of p of x is equal to, so what are the zeros? So plus or minus square root of minus 4 comma minus 2 comma plus 2. So these are the zeros of p of x. So it is so biquadratic polynomial. So the degree of this polynomial is 4. So it has 4 zeros. So plus root minus 4 minus root minus 4. 2 and minus 2 2. There are 4 zeros for the given biquadratic polynomial. So this is the fourth bit in the second problem. So we have completed a second problem. So that's all today's class. Today we will meet in the next class with another problem. Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to draw the graph of a quadratic polynomial. Very important every time he is asking for 4 marks in the public examination, so definitely you can get 1 mark from this area. So very important, you have to practice 3-4 times so you can get perfect. So totally this is a third problem from 3.2 exercise. So totally there are 5 bits in the third problem. This is the first bit. So see here, how can we draw the graph of a given quadratic polynomial, and from the graph we have to find the zeros of the quadratic polynomial. So see here what he has given. Draw the graphs of given polynomials and find the zeros, justify the answers. So first one, p of x is equal to x square minus x minus 12. So here the given polynomial is p of x equal to x square minus x minus 12. So to draw the graph of given quadratic polynomial, we have to find the ordered pairs. For that, let the given polynomial y is equal to x square minus x minus 12. So we have to find the table of ordered pairs. So by taking the x values, we have to find the corresponding y values by substituting the x values in the equation y is equal to x square minus x minus 12. So here let y is equal to x square minus x minus 12. So this is table of ordered pairs. So these are the x values. I have taken minus 3, minus 2, 0, 1, 2, 3, 4. So next what is there in the equation, we have to observe x square minus x minus 12. So we require x square value. So next x square minus x is there. Yes, I have written x square minus x. Next x square minus x minus 12. So this is x square minus x minus 12. So by writing x and y in a bracket, we can get the ordered pairs. So now I have to find, see here, these are the x values. So how can we get x square? By squaring all the x values, we can get x square values. Here it is minus 3. Minus 3 whole square is plus 9. Minus 2 whole square is 4. 0 square is 0. 1 square is 1. 2 square is 4. 3 square is 9. 4 square is 16. So these are the x square values. Simply by squaring the x values, we can get the x square values. So next we have to find x square minus x. By substituting x values from x square, we can get x square minus x. So all these are x square, all these are x values. So x square minus x, that is 9 minus of minus 3, it is 9 plus 3, 12. 9 plus 3 is 12. Directly I am writing. So here 4 minus of minus 2, it is 4 plus 2, that is 6. So 0 minus 0 is 0. So next 1 minus 1 is 0. 4 minus 2 is 2. 9 minus 3 is 6. 16 minus 4 is 12. So these are x square minus x values. So next we have x square minus x minus 12. So these are x square minus x values. By subtracting 12 from x square minus x, we can get x square minus x minus 12 values. Simply have to substitute 12 from all these values. So 12 minus 12 is 0 here. 6 minus 12 is minus 6. 0 minus 12 is minus 12. Again 0 minus 12 is minus 12. So just we have to subtract 12 from all these values. 2 minus 12 is minus 10. 6 minus 12 is minus 6. 12 minus 12 is 0. So see here what I did. Just I have subtracted 12 from all these values to get x square minus x minus 12. These are x square minus x. So x square minus x minus 12. So we want x square minus x minus 12 values. So just I have subtracted 12 minus 12 is 0. 6 minus 12 is minus 6. 0 minus 12 is minus 12. 0 minus 12 is minus 12. 2 minus 12 is minus 10. 6 minus 12 is minus 6. 12 minus 12 is 0. So next these are the y values. By writing x and y values we can get ordered pairs minus 3 comma 0, minus 3 comma 0. So next minus 2 comma minus 6, minus 2 comma minus 6, 0 comma minus 12, 0 comma minus 12, 1 comma minus 12, here it is 1 comma minus 12. So next 2 comma minus 10, 2 comma minus 10, 3 comma minus 6, 3 comma minus 6, 4 comma 0, 4 comma 0. So these are the ordered pairs of the given quadratic polynomial y is equal to x square minus x minus 12. So by plotting these ordered pairs on a graph sheet we can get a curve. So now we have to observe where the curve is intersecting the x-axis. From the points of intersection we can get the 0 values. So now we have to plot these all these ordered pairs on a graph sheet. So see here how can we plot them on the graph sheet. So now we have to plot the points on the graph sheet. Before that we have to decide the scale. So by observing the x coordinates and the y coordinates, so it is enough to take 1 centimeter as 1 unit on the x axis, but on the y axis we have to take 1 centimeter is equal to 2 units. So it is very important, before going to identify the points on the graph sheet we have to decide the scale. So the first point is minus 3 comma 0. So x is a minus 3, y is 0, it lies on the x axis. So and the second point is minus 2 comma minus 6, x coordinate is minus 2, y coordinate is minus 6. So it will be see here minus 2 comma minus 6. So this is minus 3 comma 0 after, next minus 2 comma minus 6. So identify. Next minus 2 comma minus 6. So it is minus 2 and at minus 6, yes it is minus 2 comma minus 6. X is minus 2, y is minus 6. Yes, this is a minus 2 comma minus 6. So next minus 1 comma 10. X coordinate is minus 1. Y coordinate is minus 10. So on the, yes, here it is minus 1 comma minus 10. This is minus 1 comma minus 10. So next 0 comma minus 12. So here x value is 0, y value is minus 12. It lies on the y axis. So 0 comma minus 12 lies on the y axis. Here it is 0 comma minus 12. So next we have 1 comma minus 12. So x value is 1, y value is minus 12. So here see here where it lies. So x value is 1, yes, y is minus 12. That is 1 comma minus 12. So next we have 2 comma minus 10. 2 comma minus 10. X value is 2, y value is minus 10. So see here where it lies. So here x is 2, y is minus 10. Yes, here it is. So next we have 4 comma 0. So x value is 4, y value is 0. So it lies on the x axis. So see here where it lies, 4 comma 0. Again we have to identify 4, yes, here it is 4 comma 0. Yes, it is 4 comma 0. So now we have to join the points with a smooth curve with the help of a pencil. So see here, how can we join the points? So here the point is 4, 0. So now join all the points with the help of a pencil with a smooth curve. So see here, how can we join the points? Now, yes, by passing through all the points, we have to draw a smooth curve with a free hand. So see here, like this we can join all the points with the help of a sharp pencil. So we can get the curve like this. See, you can extend the curve. Yes, we can get the curve. The name of the curve is the parabola. Here it is the parabola. So now we have to find the zeros from the graph. So here the graph is intersecting the x-axis at the points -3, 0 and 4, 0. So see here, how can we find the zeros from the graph? So from the graph, the parabola is intersecting the x-axis at the points -3, 0 and 4, 0. Therefore, the x coordinates of the points -3, 0 and 4, 0 are -3 and 4. Therefore, the zeros of p of x is equal to -3, 4. So, like this we can draw the graph of a given quadratic polynomial. So, that's all today's class, student. We'll meet in the next class with another problem. Thanks for watching. Welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to draw the graph of a quadratic polynomial. Very important for 4 marks problem. Definitely you can get a problem in the examination from this area. So very important. See here what he has given, what he is asking to find us. Draw the graphs of given polynomials and find the zeros. Justify the answers. So here second one, this is p of x is equal to x square minus 6x plus 9. So there are totally 5 bits in the third problem from 3.2 exercise. So here the given this is second bit, p of x is equal to x square minus 6x plus 9. So see here, how can we draw the graph of the given polynomial? So first, to draw any graph, we require some ordered pairs. We have to find the ordered pairs. So here he has given p of x. So let it is y is equal to x square minus 6x plus 9. Let it is y is equal to x square minus 6x plus 9. By taking some x values, we have to find the corresponding y values. So now we have to write x and y as a ordered pair. So just we have to find at least 5-6 ordered pairs for the polynomial. So see here, how can we draw the graph? So the given polynomial is x square minus 6x plus 9. So it is p of x is equal to x square minus 6x plus 9. So let it is y is equal to x square minus 6x plus 9. So let it is as y is equal to x square minus 6x plus 9. So now by taking the x values, we have to find the corresponding y values. So by writing x and y bracket we can get the ordered pairs. So see here, first for that to find the x values, so see here we have to take to find the y values we have to take the x values. So see here, let it is x, so we have to take x values here, -2, -1, 0, 1, 2, 3 and 4. So take these x values. So for these x values we have to find y values by substituting y is equal to x square minus 6x plus 9. So here what is there in the given quadratic polynomial you have to observe. So first x square is there, these are the x values. So now I am writing x square. So x square, after what is there, x square minus 6x is there. So now I am writing 6x. So next x square minus 6x. So I am writing x square minus 6x. So next x square minus 6x plus 9, it is nothing but y. So that is y, it is y. That is y is equal to x square minus 6x plus 9. So in the end we have to write the ordered pair x comma y. So like this we have to find, this is the table of ordered pairs, very important. See here how can we find the ordered pairs. So these are the x values we have to take. So if x is equal to -2, then x square is -2 whole square, directly I am writing it is plus 4. -2 whole square is plus 4. If x is equal to -1, x square is -1 whole square is again plus 1. If x equal to 0, x square is also 0. If x equal to 1, x square is 1 square is 1 only. If x is equal to 2, x square is 2 square is 4. If x is equal to 3, x square is 3 square is 9. If x is equal to 4, x square is 4 square, that is 16. So just see here, so here these are the x values we have taken. So for the corresponding x values we have found x square. Why? There is x square minus 6x plus 9 to find the y value. So we have to find x square. Just we have to square all the x values, we can get the x square value. So -2 whole square is 4, -1 whole square is 1, 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. This is x square. Next we have 6x. So just we have to multiply the x values by 6. So we can get 6x. So here 6 into -2, that is -12. So 6 into -1, -6. 6 into 0, 0. 6 into 1, 6. 6 into 2, 12. 6 into 3, 18. 6 into 4, 24. So these are the 6x values. So we have x square minus 6x. So we have to subtract 6x values from x square. So that is x square minus 6x. So I have to subtract 6x values from the x square. That is here x square minus 6x. 4 minus of -12, we can get 4 plus 12. That is directly I am writing 16. Okay. So next 1 minus of -6, it is 1 plus 6, that is 7. So 0 minus 0, again we can get 0 only. So 1 minus 6, 1 minus 6 is -5. So 4 minus 12, 4 minus 12 is -8. So 9 minus 18, it is -9. 16 minus 24, it is -8. 16 minus 24 is -8. So these are all x square minus 6x values. So next what is there? X square minus 6x plus 9. So we have to add 9 to all the values of x square minus 6x. So here 16 plus 9 is 25. So next 7 plus 9 is 16. So next 0 plus 9 is 9. So minus 5 plus 9 is how much? Plus 4. So minus 8 plus 9 is plus 1. So minus 9 plus 9 is 0. Again minus 8 plus 9 is 1 here. So next x comma y, we have to write x and y is a ordered pair. Minus 2 comma 25. It is minus 2 comma 25. Minus 2 comma 25. So minus 1 comma 16. Minus 1 comma 16. 0 comma 9. 0 comma 9. So next 1 comma 4. 1 comma 4. 2 comma 1. 2 comma 1. 3 comma 0. Next 4 comma 1. 4 comma 1. So these are the ordered pairs of the given quadratic polynomial x square minus 6x plus 9. Now we have to plot these ordered pairs on the graph sheet. So we can get a curve. From the curve we have to observe where the curve is intersecting the x-axis. From the point of intersection we can find the zeros. So now we have to plot these ordered pairs on the graph sheet. Now we have to plot the points on the graph. So before to plot the points on the graph, we have to select the scale. So here on x-axis 1 centimeter equal to 1 unit, but on the y-axis 1 centimeter equal to 5 units. That is the scale. So our first point is minus 2 comma 28. Yes, plot minus 2 comma 28. X is minus 2, y is 25. Sorry, 25, not 28. Next second one minus 1 comma 16. So x is minus 1, y is 16. So next 0 comma 9. X coordinate is 0, y coordinate is 9. Next 1 comma 4. X value is 1 and y value is 4. 2 lines before 5. So that is 4, 1 comma 4. So next 2 comma 1. X value is 2 and y value is 1. Yes, it is 2 comma 1. So next 3 comma 0. So x value is 3, y value is 0. So it lies on the x-axis. So next 4 comma 1. X is 4, y is 1. So now I have plotted all the points on the graph sheet. Now we have to draw a smooth curve by passing through all the points. See here how can we draw. Yes, draw a smooth curve by passing through all the points. So now I am removing the labels A, B, C, D, E. So these are so I am removing all the labels. Yes, G. So now we have to draw a curve passing through all the points. Yes, I have drawn a curve passing through all the points. Now it is a parabola. The name of the curve is parabola. So now we have to find the zeros of the given polynomial by observing where the parabola is intersecting the x-axis. So see here I have written the point of intersection of parabola and the x-axis is 3 comma 0. So therefore we can write From the graph, the parabola is intersecting the x-axis at the point 3, 0. Therefore, the zeros of p of x is equal to 3, 3. It has two equal zeros, so they are 3, 3. So that's all, student. This is a second bit from third problem. So in the next class we will do third bit. So thanks for watching. Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to draw a graph of a quadratic polynomial from exercise 3.2 third problem from polynomials. So already we have completed first and second bits from the third problem. So this is third bit. So see here, draw the graphs of given polynomials and find the zeros, justify the answers. So third bit, what he has given, p of x is equal to x square minus 4x plus 5. So the given polynomial is x square, p of x equal to x square minus 4x plus 5. So to draw the graph, we have to find some ordered pairs. So for that, let y is equal to x square minus 5x plus 5. Let it is as y. Now by taking x values, we have to find the corresponding y values by substituting in the equation y is equal to x square minus plus 5. So for that we have to follow these steps to find the y values. So we have to take these x values. X is equal to minus 3, minus 1, 0, 1, 2, 3, 4. So I have taken these values as x values. So by substituting x values in the equation, we have to find y values. So for that, what is there in the y equation? See here, x square minus 4x plus 5. So this is a table of ordered pairs. So this is very, very important. If you know to find the table of ordered pairs, you can draw the graph very easily. So this is very important. Table of ordered pairs is very important for drawing the graph. So now x square is there. These are the x values. So next we have to find x square. Next x square minus 4x is there. So we require 4x values. So next x square minus 4x. So x square minus 4x. X square minus 4x plus 5. So we have x square minus 4x plus 5. It is nothing but y. By writing x and y, we can get a ordered pair. So these steps we have to follow to find the ordered pairs for the given quadratic polynomial. So see here, now we have to find the ordered pairs. So these are the x values. Now we have to find x square. If x is equal to minus 3, x square is minus 3 whole square. Simply have to square all the values of x to get the x square. We have to square all. So here minus 3 whole square, we can get plus 9. Minus 1 whole square, 1. 0 square, 0. 1 square, 1. 2 square, 4. 3 square, 9. 4 square, 16. So these all are x square values. So next we have 4x in the equation, hence we have to find 4x. So just we have to multiply the x values by 4, we can get 4x values. So we have to multiply all the x values by 4. So here these are the x values. So see, while multiplying, you have to concentrate here, all these are the x values. So don't multiply with x square. So see here, we have to multiply the x values only. So these are the x values. So 4 into minus 3, we can get a minus 12. 4 into minus 3, minus 12. 4 into minus 1, minus 4. 4 into 0, 0. 4 into 1, 4. 4 into 2, 8. 4 into 3, 12. 4 into 4, 16. So these are the 4x values. So next what is there? X square minus 4x. X square minus 4x. These all are x square values. These all are 4x values. We have to subtract 4x from x square. That is 9 minus of minus 12. It becomes 9 plus 12. That is 21. 9 plus 12 is 21. So it is 1 minus of minus 4, it is 1 plus 4, that is 5. 1 plus 4 is 5. So 0 minus 0, again 0 only. So 1 minus 4 is minus 3. 4 minus 8 is minus 4. 9 minus 12 is minus 3. 16 minus 16 is 0. So these all are x square minus 4x values. But what is there? X square minus 4x plus 5 is there. Just we have to add 5 to the x square minus 4x values, we can get y value. So here 21 plus 5 is 26. 5 plus 5 is 10. 0 plus 5 is 5. Minus 3 plus 5 is 2. Minus 4 plus 5 is plus 1. Minus 3 plus 5 is 2 again. 0 plus 5 is 5. So these all are y values. So we have to write ordered pairs by taking x and y value. So it is minus 3 comma 26. Minus 3 comma 26. So next minus 1 comma 10. Minus 1 comma 10. So next 0 comma 5. 0 comma 5. So next 1 comma 2. 1 comma 2. So next 2 comma 1. Here it is 2 comma 1. So next 3 comma 2. 3 comma 2. So next it is 4 comma 5. 4 comma 5. So these are the ordered pairs. So by plotting these ordered pairs on the graph sheet, we can get a curve. So from the curve we have to observe where the curve is intersecting the x-axis. So the x coordinates of the points of intersection are the zeros. So now we have to plot these ordered pairs on the graph sheet. So now we have to plot the points on the graph sheet. Before that we have to select the scale. On the x-axis 1 centimeter equal to 1 unit, and on the y-axis 1 centimeter equal to 5 units. So first point minus 3 comma 26. So next second minus 1 comma 10. X is minus 1 and y is 10. Yes, it is minus 1 comma 10. And the next 0 comma 5. X is 0, y is 5. It lies on the y-axis. So next 1 comma 2. X value is 1 and y value is 2. So just 2 lines parallel to the x-axis above. So next 2 comma 1. So yes, it is 2 and y value is 1. 2 comma 1. Next 3 comma 2. X value is 3, y value is 2. 3 comma 2. Next 4 comma 5. X value is 4, y value is 5. It is 4. Yes, it is 4 comma 5. So now by passing through all the points, we have to draw a smooth curve with the help of a pencil. So now remove all the labels. Yes, by passing through all the points, draw a smooth curve. See here how can we draw? With the help of sharp pencil, draw a smooth curve with free hand. Then you can get a parabola again. It should be passed through all the points what we have identified. Yes, by passing through all the points, we have to draw a smooth curve. Yes, we can extend here. Yes, now this is the parabola. So to find the zeros of the parabola, we have to observe where the parabola is intersecting the x-axis. So see here, it is very clear, the parabola is not at all intersecting the x-axis. So here it is not, the curve is not intersecting the x-axis. So therefore we can say the given polynomial has no real roots. So see here, how can we write the we have to write like this, from the graph the parabola is not at all touching the x-axis, therefore there are no zeros for the given polynomial. So like this, this is the third one in the third problem. So next we have to draw the fourth one. Totally we have 5 bits in the third problem. So that's all today's class. Thanks for watching. Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to learn about the graph of a quadratic polynomial. This is the fourth one in the third problem from 3.2 exercise. Very important. Already we have completed first, second and third. Using the graph we have to find the zeros of the given quadratic polynomial. So see here, draw the graphs of the given polynomials and find the zeros, justify the answers. So fourth one, p of x is equal to x square plus 3x minus 4. So here the given polynomial is p of x is equal to x square plus 3x minus 4. To draw the graph we require some ordered pairs. For that, let a given quadratic polynomial as y is equal to x square plus 3x minus 4. To find the ordered pairs, we have to take x values as our own. For the corresponding x values, by substituting in the equation y is equal to x square plus 3x minus 4, we have to find the y values. So this is the table of ordered pairs. Let y is equal to x square plus 3x minus 4. So here we have to take these x values: minus 4, minus 3, minus 2, 0, 1, 2, 3. So for these x values we have to find the y values. So what is there in y equal to x square plus 3x minus 4. In order to find y values, you have to find x square and 3x, x square plus 3x, x square plus 3x minus 4, it is y. By writing x and y in a bracket we can get the ordered pairs. So these are the x values. Next we have to find x square. By squaring all the x values we can get x square values. So it is minus 4 whole square is 16, minus 3 whole square is 9, minus 2 whole square is 4, 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9. So all these are x square values. So next we have 3x. By multiplying the x values by 3 we can get 3x values. So 3 into minus 4 is minus 12. So 3 into minus 3 is minus 9. 3 into minus 2 is minus 6. 3 into 0 is 0, 3 into 1 is 3, 3 into 2 is 6, 3 into 3 is 9. So you have to concentrate on the x values only while multiplying with 3. So don't multiply with x square values. So here 3 into x is there. You have to multiply only x values. So next x square plus 3x. This is x square values. These are 3x values. Just we have to add these two. So 16 minus 12, it is 4, 9 minus 9, it is 0, 4 minus 6 is minus 2, 0 plus 0 is 0, 1 plus 3 is 4, 4 plus 6 is 10, 9 plus 9 is 18. So these are x square plus 3x values. So next x square plus 3x minus 4. So these are x square plus 3x values. We have to subtract 4 from all the values. So here 4 minus 4 is 0. 0 minus 4 is minus 4. Minus 2 minus 4 is minus 6. 0 minus 4 is minus 4. 4 minus 4 is 0. Again here 10 minus 4 is 6. 18 minus 4 is 14. So 18 minus 4 is 14. Now these are the x values and these are the y values. By writing these two we can get the ordered pair. So first one is minus 4 comma 0. So next second one minus 3 comma minus 4. Minus 3 comma minus 4. Next it is minus 2 comma minus 6. Minus 2 comma minus 6. 0 comma minus 4. 0 comma minus 4. 0 comma minus 4. So next 1 comma 0. 1 comma 0. So next 2 comma 6. 2 comma 6. So next 3 comma 14. 3 comma 14. So these are the ordered pairs of the given quadratic polynomial x square plus 3x minus 4. So now we have to plot all these ordered pairs on the graph sheet. We can get a curve. So we have to observe where the curve is intersecting the x-axis. So from the points of intersection we can get the zeros. So now we have to plot all these ordered pairs on the graph sheet. So finding ordered pairs is very important. If you find ordered pairs easily, you can draw the graph very easily. So now we have to plot these ordered pairs on the graph sheet. So now we have to plot the ordered pairs on the graph sheet. Before that we have to select the scale. So on the x-axis we have to take 1 centimeter is equal to 1 unit, but on the y-axis 1 centimeter equal to 2 units is enough. So now first point is minus 4 comma 0, x value is minus 4, y value is 0, so it lies on the x-axis. Yes, it is minus 4 comma 0. So next minus 3 comma minus 4, x is minus 3, y is minus 4, this is minus 3 comma minus 4. So next minus 2 comma minus 6, x value is minus 2, y value is minus 6, it is minus 2 comma minus 6. So next 0 comma minus 4, x is 0, y is minus 4, it lies on the y axis at minus 4. So next 1 comma 0, x value is 1, y is 0, it lies on the x axis at 1. So next 2 comma 6, x value is 2 and y value is 6. So these points are enough to draw the graph. So by passing through all the points we have to draw a smooth curve with the help of a sharp pencil. So see here how can we draw. Now here there are labels A, B, C, D, F. We can remove these labels. We don't require the labels. Now I am removing all the labels. See here now removing all the labels. Yes, I have removed all the labels. Now by passing through all the points we have to draw a curve with the help of a sharp pencil. Yes, like this we have to draw the curve. So it should passes through all the points. Yes, this is a parabola. So now where the parabola has intersected the x-axis we have to observe. Now from the points of intersection of the parabola and the x-axis we can find the zeros of the given polynomial. So see here now I am writing the values where the parabola has intersected the x-axis. So the first point is 1 comma 0 and here also the second point of intersection is minus 4 comma 0. 2 visible, very clear. I am changing the color. Yes, it is minus 4 comma 0. So next it is 1 comma 0. So now from the points of intersection we can find the zeros of the given polynomial. So here, see here, the graph, we can say from the graph the parabola is intersecting the x-axis at the points minus 4 comma 0 and 1 comma 0. Therefore zeros of p of x is equal to minus 4 comma 1. So these two are the zeros of the given quadratic polynomial. So this is the fourth bit in the third problem. There is one more bit, fifth bit. Totally there are 5 bits. In the next class we will do the fifth bit. That's all today's class. Thanks for watching. We will meet in the next class. Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to draw a graph of the quadratic polynomial from exercise 3.2 third problem. This is fifth bit. So there are 5 bits in the third problem. Already we have completed 4 bits. This is the fifth bit. So very important it is. Draw the graph of the polynomial and find its zeros. He asks in the examination for 4 marks. So definitely you can get a graph on the quadratic polynomial. So you have to concentrate and draw and practice at 3-4 times so you can get perfect. So see here what he has given in the fifth one. Draw the graphs of given polynomials and find the zeros, justify the answers. So fifth one, p of x is equal to x square minus 1. So it is very easy. So the given, comparing to the remaining 4, it is very easy. So it has only x square and constant. There is no x term here. To find the ordered pairs, it is very easy to find the ordered pairs. So here p of x is equal to x square minus 1. The given polynomial is p of x equal to x square minus 1. To find the ordered pairs, let it is y is equal to x square minus 1. So y is equal to x square minus 1. So by this is the table of ordered pairs. By taking the x values, we have to find the corresponding y values by substituting the x value in the equation y is equal to x square minus 1. So here these are the x values. So I have taken x minus 3, minus 2, minus 1, 0, 1, 2, 3. So here we have to find what is there in equation to find. In order to find the y values, we have to find first x square. We require, yes, we have to find x square values. So next x square minus 1 is there. So this is y is equal to x square minus 1. By writing x and y, we can get the ordered pairs. So see here, all these are the x values. Now we have to find x square. By squaring all the values of x, we can get x square values. So here it is minus 3 whole square. Minus 3 whole square is 9. Minus 2 whole square is 4. Minus 1 whole square is 1. 0 square is 0. 1 square is 1. 2 square is 4. 3 square is 9. So just we have to square the all values of x to get x square values. So this is x, these are the x square values. Next, what is there? X square minus 1 is there. Just we have to subtract 1 from all the values of x to get x square minus 1. So here 9 minus 1 is 8. 4 minus 1 is 3. 1 minus 1 is 0. 0 minus 1 is minus 1. Here also 1 minus 1 is 0. 4 minus 1 is 3, 9 minus 1 is 8. So these are the y values, x square minus 1, y is equal to x square minus 1. So by writing x and y, we can get the ordered pairs. Minus 3 comma 8, this is the first ordered pair. Minus 3 comma 8. So next minus 2 comma 3, this is second one. Minus 2 comma 3. So next minus 1 comma 0, third one, minus 1 comma 0. So next 0 comma minus 1, 1 comma 0, 2 comma 3, 3 comma 8, 3 comma 8. So these are the ordered pairs. Now by plotting these ordered pairs on a graph sheet, we can get the curve of a corresponding polynomial. So now we have to observe where the curve is intersecting the x-axis in order to find the zeros of the quadratic polynomial. So now we have to plot all these ordered pairs on a graph sheet. So see here how can we plot these ordered pairs on the graph sheet. So now we have to plot the points on the graph. Before that we have to select the scale. On x-axis 1 centimeter equal to 1 unit and y-axis 1 centimeter equal to 1 unit. The first point is minus 3 comma 8 and so here minus 3 comma 8, yes it is minus 3 comma 8. So next minus 2 comma 3. Second one is minus 2 comma 3, x is minus 2, y is 3. Here it is minus 2 comma 3. So next minus 1 comma 0, it lies on the x-axis at minus 1. This is minus 1 comma 0. Next 0 comma minus 1. So x is 0, y is minus 1. Next 1 comma 0. X is 1, y is 0, it lies on x-axis at 1. 2 comma 3, x is 2, y is 3. Next 3 comma 8, x is 3, y is 8. So now we have to disable the labels. Disable all the labels, we don't want a b c d f g. So now we have to see here again disable g also. So now by passing through all the points we have to draw a smooth curve with the help of a sharp pencil. So here see here how can we draw the curve. By passing through all the points we have to draw a smooth curve with a sharp pencil. So see here like this we have to draw the curve. It should be passes through all the points where we have identified on the graph sheet. So see here this is the parabola. What it is, a parabola? So from the parabola now we have to find the zeros by observing the parabola where it is intersecting the x-axis. So now we have to write the zeros. See here from the graph the parabola is intersecting the x-axis at the points minus 1 comma 0 and 1 comma 0. Therefore zeros of p of x is equal to minus 1 comma plus 1. So these are the zeros of given quadratic polynomial. So this is the fifth bit. Totally we have completed all 5 bits in the third problem. So that's all student. In the next class we will do another problem. So thanks for watching. Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to solve a problem from Polynomials exercise 3.2 fourth problem. See here already we have completed first, second and third problem from 3.2 exercise. This is fourth problem. See here what he is asking to find us. Why are 1 by 4 and minus 1 zeros of polynomial p of x is equal to 4x square plus 3x minus 1. So he has given a polynomial p of x equal to 4x square plus 3x minus 1. Then why are 1 by 4 and minus 1 are the zeros of p of x is asking. Suppose if we replace 1 by 4 by x in the p of x, if we get p of 1 by 4 is equal to 0, then we can decide 1 by 4 is a 0 of p of x. So in the same way, if we substitute x equal to minus 1 in p of x, so if we get p of minus 1 is equal to 0, again we can decide that minus 1 is also a 0 of p of x. Just simply how to substitute once x equal to 1 by 4 and next x equal to minus 1 and p of x. If we get p of 1 by 4 is equal to 0 and p of minus 1 is equal to 0, we can say that 1 by 4 and minus 1 are the zeros of p of x. So see here how can we solve. So p of x is equal to what he has given. P of x is equal to 4x square plus 3x minus 1. So this is p of x. So now we have to substitute x equal to 1 by 4. So substituting x equal to 1 by 4. So see here we get p of 1 by 4 is equal to p of 1 by 4 is equal to. So substitute x equal to 1 by 4 in p of x. So 4 into x square is there. So we get 4 into 1 by 4 whole square plus 3 into x is there. So 3 into 1 by 4 minus 1 right as well. So just I have substitute x equal to 1 by 4 in p of x. So p of 1 by 4 is equal to 4x square, that is 4 into 1 by 4 whole square plus 3x, 3 into 1 by 4 minus 1. So we have to simplify. So 4 into 1 by 4 whole square, it is 1 by 4 into 1 by 4, we get 1 by 16 plus 3 into 1 by 4, we get 3 by 4 minus 1. So here 4 ones and 4 fours are 16. So here it is 1 by 4 plus 3 by 4 minus 1. So see here denominators are same, we can add the numerators. So for these two only, so it becomes 1 plus 3 by 4 minus 1. 1 plus 3 is 4 by 4 minus 1. 4 by 4 is 1, that is 1 minus 1, which is 0. So here p of 1 by 4 is equal to 0, therefore 1 by 4 is a 0. So see here since p of 1 by 4 is equal to 0, 1 by 4 is a 0 of p of x. 1 by 4 is a 0 of p of x. So again we have to substitute x is equal to minus 1 in p of x. See here p of x equal to 4x square plus 3x minus 1. Substitute x is equal to minus 1. So substituting x is equal to minus 1 in p of x. Substituting p of x. So what we get? P of minus 1. P of minus 1 is equal to. So wherever x is there, substitute minus 1. P of minus 1 equal to 4x square. That is 4 into minus 1 whole square plus 3x is there. 3 into minus 1, again minus 1 is there. So this is p of minus 1. So 4 into minus 1 whole square is minus 1 into minus 1, we get plus 1. So 4 into 1 plus 3 into minus 1 is minus 3 minus 1. So 4 into 1 is 4. So this minus 3 minus 1 is minus 4. So 4 minus 4 is equal to 0. So since p of minus 1 is equal to 0, minus 1 is a 0 of p of x again. So since p of minus 1 is equal to 0, minus 1 is a 0 of p of x. So therefore we can write 1 by 4 and minus 1 are zeros of p of x. Zeros of p of x. So like this we can. So therefore since p of minus 1 is equal to 0, minus 1 is a 0 of p of x. So 1 by 4 is a 0 of p of x and minus 1 is a 0 of p of x. Therefore, we can write 1 by 4 and minus 1 are zeros of p of x. So this is fourth problem in the 3.2 exercise. So totally we have completed all the problems in 3.2 exercise, including introduction, graphical representation of polynomials. So in the next class we will learn relation between the coefficients and the zeros of the polynomials. So that's all today's class. Thanks for watching.